Welcome back to Chem Talks once again. Alright guys, we are starting our third unit, and this honestly is going to be the most important unit of the entire year. Why? Because what we learn now is going to play into everything we do for the rest of the year. So if you got to make sure you get this down. If you're having problems, as always, this is really important to come and see me. This is the second most important thing that we need. I said you need to know two things to do really well: factor labeling, which you've already talked about, and how to write chemical formulas. This is the start of that how to write chemical formulas. Okay, so pay attention guys. I guarantee you'll get a charge out of this one. Yeah, bad joke, I know. So let's go ahead and get started talking about ions. An ion, as we talked about earlier when we talked about atomic structure, is simply an atom with a charge. Okay, it can be either a positive or negative charge. Remember, it gets that charge by either gaining or losing electrons, not protons. We can't change the number of protons because that changes the identity of the element, but we can change the number of electrons. So we either gain them. If we gain electrons here, we become a negative ion. If we lose electrons, we become a positive ion. The reason is positive, we have more protons than electrons, so more pluses and minuses. If we gain an electron, we have more negatives than we do positive. Pretty simple math there. Why is this important? Well, like I said, this is going to play into everything we do for the remainder of the year. It's the charge of the particular atom that determines what other elements it will bond to and what combination it can bond with other elements and properties of elements. So it's really important that we get this down. Eventually, when we start writing chemical formulas, you're going to have to be able to look at 2, maybe 3, 4 different elements and say, okay, how are they going to combine? And this is where that starts today. So make sure you are paying attention. Okay, ions fall under two basic categories based on, are they a positive or a negative? Okay, if you lose electrons, you're going to be called a cation. If you're losing electrons, you're going to have more pluses, more protons than electrons, and you have a positive charge. And this is generally characteristics of metals, which remember we find to the left of that diagonal line on the periodic table. Now if you gain electrons, we call it an anion. Okay, it has a negative charge, so you'll have more electrons than you do protons. This is a characteristic of the nonmetals, which are on the right hand side of that stair step. Good little hint for remembering this. An anion, for me, it stands for a negative ion. It's a good way to remember that. I'll tell you another one about the cat in class, how to remember that. So cations lose electrons, have a positive charge. Anions gain electrons, have a negative charge. Okay, what determines whether they gain or lose electrons? That's going to be found in what we call the valence electrons. Valence electrons are electrons that occupy the highest energy. Think about when we talked about quantum numbers, okay? The principal quantum number was that energy level, okay? And that always basically involved the s and p orbitals, okay? So how many electrons do we find in s and p combined? Well, we know s can hold 2, p can hold 6, so we have a total of 8, okay? And these valence electrons are then going to determine how an element bonds with other elements, okay? Because it's going to determine the charge. For example, if we look at carbon, okay, here is our electron configuration for carbon. If we look at the highest quantum number, which is 2, we have 2 in the s's, 2 in the p's, so carbon has 4 valence electrons. Look at bromine. Here's a shortcut for bromine. We see our final quantum here. Our highest number is 4. Okay, 3, that's lower. We don't worry about it, but it has 2 in the s's and 5 in the p's. So bromine has a total of 7 valence electrons. Okay, and these are going to determine how or whether the element gains or loses electrons when it becomes an ion. Okay, so the number of valence in an element is the same as the group number. A quick and easy way to figure out the number of valence electrons is to look what group number it is. I would be great if you'd remember it has to do with a total of combination of S plus P, and I really want you to understand it, but the cheat way to do it is to look what group number it is in. Okay, if we're talking our representative elements, okay, that's the 1A, 2A, all the way up to 8A. Okay, so the group number that it's in tells you how many valence. So, for example, Group 1A has one valence electron, that's hydrogen. If we go over to group 2A, they're all going to that column is going to have 2. 4A is going to have 4. 5A is going to have 5. 8A is going to have 8. Okay, it's a real simple, easy way to remember this. It'd be great if you explained to me in relation to quantum numbers, but if you can't, you got to remember, the easiest way to do it is what column it's in. Okay, when we're talking representative, that tells you how many valence electrons are in there. Okay, to kind of illustrate these valence electrons, we use something called electron dot notation, also known as Lewis dot diagrams. It's basically just a pictorial representation of the valence electrons, and they're really easy to draw. Okay, first thing you're going to do is write the element symbol. Well, we just copy that off the periodic table, and then we are going to put a dot around the symbol for each of the valence electrons. Remember, the number of valence electrons is equal to whatever column number it's in. So let's look at helium. Helium we see is on the far right. Okay, this is a weird one to start with because it's technically in 8A. Okay, but we know helium only has 2 protons, so it has to have 2 electrons as well. So what we're going to do is put dots around there. There's 1, there's 2. Okay, probably not the best example to start off with. Let's look at another one though. Look at nitrogen. Okay, if we look at nitrogen, it's in group 5A, I believe, and so it should have 5 dots on them. I always put my dots in the directions north, east, south, west, and go back and double up. So we have 1 north, east, south, west, north. And there's our Lewis dot diagram or electron notation for nitrogen. How about chlorine? Chlorine is in group 7A, so it should have how many valence electrons? You're right, 7. So let's put them in. 1, 2, 3, 4, 5, 6, 7. So real simple there. Okay, not rocket scientists. You guys can all do this. Okay, the reason valence electrons are important is that all elements want to have a stable electron configuration. Okay, it makes them happy. What we mean by this is atoms tend to react with each other by changing the number of electrons so as to acquire what we call a stable electron configuration in nearest noble gas. So they want to look like their nearest noble gases. If we look at all our noble gases except helium, they have 8 electrons, valence electrons. So atoms or elements are either going to gain electrons to become like the one in front of them, or they're going to lose them to become like the noble gas behind them. Okay, and this is following what we call the octet rule. The octet rule says that atoms tend to gain, lose, or even share electrons in order to acquire a full set of these valence electrons. And that's what they're going for. When they have this full set of valence electrons, they have a stable electron configuration. Everybody likes to be stable. You don't want to be unstable. Okay, so they want to look like their nearest noble gas. And as I said, that can either be in front of them, to the right of them, or it can be behind them. Okay, depending on what their configuration is, they're going to move one way or the other. Okay, they do this to have a full valence shell. That means all their the S and the P have are full, meaning a total of 8 electrons. Okay, how do we form ions? Well, there's 2 general rules we want to go to. If an atom has 3 or less valence electrons, they tend to lose them and become positively charged. Okay, so we're talking the right-hand side. These are our metals. So metals generally form positive. Okay, if an atom has 5 to 7 valence electrons, as on the right-hand side are nonmetals, they will tend to gain electrons to fill their valence shell and become negatively charged. They're gaining electrons. They're going to have more negatives than positives. Well, what about 4? Like carbon. Well, carbon can go either way, and we don't mess with it a whole lot in this class. We do it more in a different type of bonding in organic chemistry, which we'll talk about later. Okay, so keep this in rule. If it has 3 or less valence electrons, it's easier for them to lose those electrons than to gain enough to become like their nearest noble gas. Okay, if it has 5 through 7, it's easier just to gain a couple rather than lose all those to become like the nearest noble gas behind them. Okay, the actual charge that an atom gets when it forms an ion, okay, is determined by comparing the number of protons and electrons in the ion. If there are more protons in it than electrons, after it either adds or takes away electrons, it's going to be a positive ion, a cation. So these are our metals. If there's more electrons than protons, you form a negative ion or an anion. And the actual numerical value is the difference between the number of protons. So it's the number of electrons you either added or taken away. So hydrogen, for example, is +1. Chlorine is -1. Oxygen, -2. Okay, because we gained 2 electrons. Pretty easy to follow along with this, but it's really important that you understand this. So let's look at a couple examples here. Nitrogen, we looked at this already. Nitrogen has 5 protons, which means it has 5 electrons. Okay, it's in group 5A, so it has 5 valence electrons. If we write this Lewis dot diagram, it looks something like this. Okay, so 5 electrons, that's in the 5 through 7 group, so it's going to gain electrons to become like its nearest noble gas, which is neon. Okay, that is 8. So in order to become 8, it has to gain 3 electrons. Take a look at your periodic table to see this. Okay, and so now it has 5 protons, 8 electrons. Okay, the difference is 3 electrons. So the charge in nitrogen becomes -3. We can do a Lewis dot diagram. There's how we write write nitrogen. We can do a Lewis dot diagram like that. The x's represent the elements that we added, the electrons that we added, and then we'll just put our negative charge there. We'll talk about that here in just a second. Okay. Okay, let's take a look at the periodic table and summarize this real quick. We said that our first 3 groups of representative, 1A, 2A, 3A, in metals, tend to lose electrons, become positive. Groups 5, 6, 7A tend to gain electrons, become negative. So everybody in group 1A, that's hydrogen, lithium, all those, they're going to have 1 valence electron. They lose that valence electron and become a +1 charge. Okay, group 2 is going to be a +2 charge because beryllium is in group 2, so it has 2 valence electrons. It loses those 2, has 2 more protons, becomes a +2. What do you think about boron? It's in group 3A, so it has 3 valence electrons. It loses those, becomes a +3. We're only going to worry about boron and aluminum in there for right now. Okay, we said we're going to skip carbon. Nitrogen, we just did this one. It's in group 5A, so it's got to gain 1, 2, 3 electrons to become like neon, so it's a -3 because it's gained electron. Oxygen's got to gain 1, 2, so it becomes a -2 charge. And then fluorine has to gain 1 electron to become like neon. It's a -1. So think of it as like climbing a mountain. +1, +2, +3. We hit the plateau, the summit, and then we start going down. -3, -2, -1. You need to be able to look at a periodic table at any time and tell me calcium +2, chlorine -1. Okay, you need to be able to do it that quick. It's going to be that important, so make sure you know it. Now there are 3 other elements on here you need to know. First one is gold and silver. Ag is silver, Au is gold. They have a +1 charge. The other one you're going to need to have memorized is zinc. It's +2. A good way to memorize these, or a little trick, it has nothing to do with their actual reason they're this, but this column here is 1B. If you look at the periodic table in the classroom, this one is 2B. So zinc's in 2B, it's a +2. Gold and silver are in 1B, it's a +1. It has nothing to do with their actual charge. It's just a little trick to remember it. Okay, so we did electron diagram notation, Lewis dot diagrams for the element. Now let's look at it for the ion. So it's simply a pictorial representation of ions. Okay, it's the Lewis dot diagrams for ion. You're going to show differences. You show either the added or removed electrons. We do it the same way. Okay, and you also show the charge of an ion. So here's nitrogen. Okay, we said nitrogen to be like neon needs to gain 3. So I'm going to put 1, 2, 3. You can either dots. I like to put X's usually to represent them. And then we're gain 3. So we're going to put brackets around this and show the -3 charge, meaning it gained 3. If we look at something like sodium, sodium has 1. Okay, so if we look at that, it's easier to lose 1 than it is to gain 7. So we get rid of that. Okay, and then it has a +1 charge. All anions or negative ions are going to look like nitrogen here. They're going to have 8 valence electrons on them. They're going to have some element symbol here, and they'll have a charge there. All cations are going to look like sodium. They're going to have some element symbol and then a charge with no dots around them. Okay, so anions always have 8 dots around them with a charge. Cations always have no dots around them with a charge. So pretty simple way to remember what they look like. Okay, naming ions. This is the start of naming. We're going to name lots of stuff. And naming Cations is really quick, easy. Remember, cations are positive ions. They lost electrons, became positive. They're on the left-hand side. They're metals. So what you're going to do is the name is the same as the element. You're just going to add the word ion and end it. For example, H plus becomes hydrogen ion. Sodium plus 1 becomes sodium ion. Notice on both these, even though it's a +1 charge, we just put a plus. We didn't have to write the 1. If there's a plus there, we assume there's a 1. Magnesium, which is +2, we call it a magnesium ion. Spelling counts. Make sure you spell the element name correctly, guys. Make sure you review your note cards on that. Anions on the other hand, are a little trickier. Okay, remember, anions are negative ions. They gained electrons. They're on non-metals right-hand side. What you're going to do is change the suffix or the ending of the name to IDE. You already know a bunch of these. So when you go to do them, think about ones you know. For example, fluorine becomes fluoride. Watch the spelling on this one's a tricky one. Okay, chlorine becomes chloride. Oxygen comes oxide. You know these guys. Pretty simple. Just go back to these, say fluoride, chloride, oxide, and then apply this suffix IDE ending to any of them. Alright guys, thanks for tuning in. Like I said, Unit 3 is probably the most important that we're going to do because everything we do in this is going to follow through to the end of the semester. Actually, end of the year, not just the semester. So you need to make sure you understand it. Okay? Review where the charges are. It'd be great if you could explain them, their valence electrons in terms of s and p orbitals. If not, know that the number of valence electron is equal to the column they're in and the representatives, that's the A's. Okay, and then know that groups 1A, 2A, 3A tend to lose their electrons because these are lose them then gain a bunch and become positive because they have more protons and electrons. Group 5, 6, 7 gain the electrons to become like their nearest noble gas. Okay, and they gain them to become electrons. So make sure you understand this. Any questions, please come and see me, guys. Until then, have a good evening and we'll talk to you in the next class. Take care.